What is total productive maintenance? This video is made in collaboration with Lean Community. Join the Lean community now and start using the Lean token. This video has the ambition to become the definitive guide to knowing and implementing total productive maintenance, also known as TPM. The tutorial will be divided into chapters, and in the description, you will find documents and checklists to download to have a written reference and to be guided in the implementation of the TPM step by step. In particular, the following topics will be discussed. What is the TPM and why it is important? The history of the TPM. The 6 big losses. The 8 pillars of the TPM. TQM vs TPM. The different types of maintenance. The 9 steps to implement autonomous maintenance. Practical tips for TPM. Ready, go. Chapter 1. What is TPM and why it matters? The purpose of the TPM is to have zero unscheduled downtime. To achieve this, the TPM aims to have only planned downtime, for example, for preventive maintenance. The key to TPM success is to perform preventative maintenance effectively and efficiently. In other words, the right maintenance must be done at the right time to ensure that the machinery is up and running when needed. To better understand what TPM is and why it is important, I want to give you the example of your car. Most likely, you do the oil and filter changes on your car on a periodic basis. Also, change your tires every 20,000 kilometers before they wear out and deflate during a trip. In other words, do you prefer a planned stop or an accidental stop with your car? Well, the same care you have for your car should be carried on your company's equipment. Chapter 2. The history of the TPM. The TPM is a methodology born in Japan. After the Second World War, the Japanese industry was devastated, and the industrial leaders, to start again, began to adopt the American philosophies of quality management and quality control. It is history that Dr. Deming made many trips to Japan to teach total quality management. In those years, the Japanese industry began to build and use automatic equipment. The use of automatic equipment created the belief and the mindset that only specialized technicians could intervene on the machines. This mindset created a distance between the line operators and the machines they were working on. I work, you fix. This separation and this mentality quickly led to a loss of production capacity and unplanned and prolonged downtime. Just as quickly, the Japanese realized that they would not meet their delivery and quality targets with machinery that frequently broke down. So around 1950, the leaders focused on preventive maintenance. Preventive maintenance is the concept of daily maintenance aimed at keeping the machinery in good operating condition and avoiding breakdowns. Unfortunately, even with the adoption of preventive maintenance, the separation between maintenance personnel and line operators was still great, and the machinery continued to stop, proving not suitable for achieving the set objectives. In 1960, the Denso company introduced the concept of autonomous maintenance, where the line operator had to perform a routine maintenance on the machine he was working on. This practice freed up time for specialized maintenance workers who could better dedicate themselves to preventive maintenance and technical improvement of the equipment. The combination of autonomous maintenance, preventive maintenance, and improvement led to the birth of the TPM. According to the JIPM, Japan Institute of Plant Maintenance, the first definition of TPM was made in 1971, then in 1989 it was revised. Chapter 3. The 6 big losses. It should now be clear to you that one of the purposes of the TPM is to make plants more efficient. By having more efficient systems, you can work more peacefully and help increase company profits. Making plants more efficient means eliminating the losses that reduce efficiency in general. For machinery, losses are classified into 6 categories. 1. Equipment failure. 2. Setup and adjustments. 3. Idling and minor stops. 4. Reduced speed. 5. Process defect. 6. Startup losses. It is very important to know and be able to classify these losses in order to implement effective countermeasures to eliminate them. Let's now go into the details of each loss. Equipment failure. Breakdown losses occur when a machine breaks down and maintenance needs to repair it. How many hours a month are lost in the ward or on the line for this reason? Setup and adjustments. Today's world is characterized by a high demand for differentiation and small batch sizes. The production must therefore carry out type changes several times a month. But how long does it take for the type change if the molds are very heavy? What if there are many screws and bolts to screw in and out? What if the adjustments are very complex and can only be done by an expert? Idling and minor stops. When the pieces stop on a chute of an automatic machine, the operator solves it by himself and does not call for maintenance. This is a classic example of a minor stops. The sum of these minor stops, perhaps on several machines, can lead to a large loss of production capacity at the end of the shift. Reduced speed. Some plants, if not properly maintained, can meet the quality requirements only if they work at a speed lower than the nominal one. Process defect. Deming said, "Defective parts are never free, someone pays to make them. It is useless to work, even with the utmost effort, if defects are produced in the end." Startup losses. A classic example of startup losses is when a machine needs time after being switched on in winter to bring the working oil to the right temperature. Now that you know the 6 big losses, you must learn to observe them, recognize them, and measure them correctly. When you have the measurements, you can calculate overall equipment effectiveness. For the definition of the OEE and how to calculate it, I leave you a series of in-depth videos in the description. Chapter 4. The 8 Pillars of the TPM. In the literature, a model of implementation of the TPM is often proposed with the figure of a temple with 8 pillars that must be built in order and in time. Following the road of the 8 pillars, we will no longer stop at the machines alone, but the improvement will affect the complete organization. You can find a slightly different order based on the source. Here I propose the sequence of the JIPM, Japanese Institute of Plant Maintenance. Pillar 1. Autonomous maintenance. Operators who use all of their senses to help identify causes for losses. Pillar 2. Focused improvement. Scientific approach to problem solving to eliminate losses from the factory. Pillar 3. Planned maintenance. Professional maintenance activities performed by trained mechanics and engineers. Pillar 4. Education and training. Support to continuous improvement of knowledge of all workers and management. Pillar 5. Early management. Scientific introduction of equipment and design concepts that eliminate losses and make it easier to make defect-free production efficiently. Pillar 6. Quality maintenance. Scientific and statistical approach to identifying defects and eliminating the cause of them. Pillar 7. Safety, health, and environment. Scientific approach to solutions that will improve the safety, health, and environment. Pillar 8. Office TPM. Using TPM tools to improve all the support aspects of a manufacturing plant, including production scheduling, materials management, and information flow. Chapter 5. TQM versus TPM. Total quality management and total productive maintenance are often used interchangeably. However, TQM and TPM share a lot of similarities, but are considered as 2 different approaches in the official literature. TQM attempts to increase the quality of goods, services, and concomitant customer satisfaction by raising awareness of quality concerns across the organization. TQM is based on 5 cornerstones. 1. The product. 2. The process that allows the product to be produced. 3. The organization that provides the proper environment needed for the process to work. 4. The leadership that guides the organization. 5. commitment to excellence throughout the organization. In other words, TQM focuses on the quality of the product, while TPM focuses on the losses that impede the equipment used to produce the products. TQM and TPM can both result in an increase in quality. However, the way of going there is different. TPM can be seen as a way to help to achieve the goal of TQM. Chapter 6. The different types of maintenance. 4 general types of maintenance philosophies can be identified, namely corrective, preventive, risk-based, and condition-based maintenance. 1. Corrective maintenance. Maintenance is carried out following detection of an anomaly and aimed at restoring normal operating conditions. This approach is based on the firm belief that the costs sustained for downtime and repair in case of fault are lower than the investment required for a maintenance program. This strategy may be cost-effective until catastrophic faults occur. 2. Preventive maintenance. Maintenance carried out at predetermined intervals or according to prescribed criteria, aimed at reducing the failure risk or performance degradation of the equipment. The maintenance cycles are planned according to the need to take the device out of service. The incidence of operating faults is reduced. 3. Risk-based maintenance. Maintenance carried out by integrating analysis, measurement, and periodic test activities to standard preventive maintenance. All equipment displaying abnormal values is refurbished or replaced. In this way, it is possible to extend the useful life and guarantee over time high levels of reliability, safety, and efficiency of the plant. 4. Condition-based maintenance. Maintenance based on the equipment performance monitoring and the control of the corrective actions taken as a result. The real actual equipment condition is continuously assessed by the online detection of significant working device parameters and their automatic comparison with average values and performance. Maintenance is carried out when certain indicators give the signaling that the equipment is deteriorating and the failure probability is increasing. Chapter 7. The 9 Steps to Implement Autonomous Maintenance. Peter Wilmot, UK TPM Guru, has proposed a widely used 9-step model. The 9-step process is a long and thorough one. Absolutely not a quick fix. Step 1. Collect equipment history and performance analysis. This step focuses the project and sets measurement objectives, for example cost, OEE, material savings. Step 2. Define and calculate OEE. Clarify the meaning and interpretation amongst team members. Set up an OEE display board at shop floor. Brainstorm out possible causes and display on a chart. Step 3. Assess 6 big losses and set priorities. This will involve an analysis such as shown in the last section. Agree and sign off the priorities with management. Step 4. Critical assessment. Produce a list of all components of the relevant machines. Discuss and understand the role of each component and their interdependencies. Not superficially, but in detail. Discuss the optimal conditions for the operation of each critical component, e.g., temperature, lubrication, cleanliness, sharpness. Then define the normal operating conditions. Step 5. Initial cleanup and condition appraisal. Agree the cleaning areas. Source all necessary and specified cleaning equipment. Photograph the current state. Systematically inspect every part of the machine in detail. Clean and inspect, capturing problems found. Develop a cleaning and inspection program. Cleaning is checking. Identify sources of contamination, internal and external, and develop a plan to eliminate, isolate, and prevent contamination. Step 6. Plan refurbishment. Develop a phased refurbishment schedule covering item, labor hours planned completion, and PDCA cycle stage. Look into POCA yoke and quick changeover and undertake this where necessary. Step 7. Develop asset care. Clearly define the role and the tasks of the operator. Produce a clean and check list with appropriate frequencies. Develop a Kamishibai board covering the phased and daily activities of maintenance, safety, quality, and operator checks. Identify, mark, and color code all gauges, pipework, lubrication points, levels, and sight classes, nut positions. Step 8. Develop best practice routines and standards. Taking all that has been learned in previous steps, assemble a best practice manual. Develop single pont lessons where necessary. Review standard operating procedures and maintenance instructions. Again, think of your car. At least 30 checks are possible without any mechanical knowledge. Step 9. Problem prevention. This is an improvement cycle. OEE leads to the particular loss being identified, leading to the issues that are tackled by the 5 whys and often by a 3 analysis. All of this feeds back to earlier stages to complete the cycle. Chapter 8. Practical tips for TPM. Tip number 1. Be guided by an expert. It is very important, if you are at the beginning, to be guided by an expert who can explain the first steps on the basis of consolidated experience. Benjamin Franklin said, "Education is the investment with the greatest returns." Tip number 2. Don't start with a company-wide TPM program. You start with one machine and focusing on only one of the 3 components of the OEE, for example, availability. When you have measured and improved the first factor, spread to the others, and then to other machines. Tip number 3. Plan adequate resources for maintenance. If you don't plan adequate resources in terms of people and spare parts, the first results you will get on the first machine will inevitably be lost when you move to other machines. There are many other practical tips for implementing the TPM, and I invite you to join the Lean Community Discord server to find experts available to answer all your questions. Find the link in the description. Conclusions. The TPM is a program created to maximize the production capacity of the machines. TPM needs method, time, and adequate resources to be effective. It is proven that the investment made in a serious TPM program has an economic return for companies. If you want to know more, you can find TPM experts on the Lean Community Discord server. Find the link in the description.